Hello everyone, I'm Dr. Hodges and welcome back to another episode of Technology and Cybersecurity Explained. In today's session, we're focusing on one of the most important areas in modern cybersecurity: how to properly secure cloud environments and the essential principles behind Zero Trust. Now let's talk about what makes securing modern cloud environments fundamentally different from securing traditional on-prem environments. First, distributed environments. Our infrastructure is no longer sitting in one building or one data center. It's spread across multiple clouds, SaaS platforms, remote users, mobile devices, and edge locations. This means the attack surface is everywhere, and our security models must be built for scale and distribution. Second, identity is the new perimeter. In the cloud, network boundaries don't protect us the way they used to. Instead, identity, who or what is requesting access, becomes the most important security control. Users, devices, workloads, APIs, and service accounts all need strong authentication and authorization. This is the core of Zero Trust. Third, shared control models. Cloud security is a partnership. Providers handle physical infrastructure and some platform security, but customers still own identity, configuration, data protection, and access. Most security failures in the cloud come from misconfigurations, not provider issues, so understanding shared responsibility is essential. Fourth, evolving threats. Adversaries know organizations are moving to the cloud, and they're adapting their tactics. We're seeing more identity attacks, API abuse, token theft, and attacks on cloud services that didn't exist in traditional networks. Cloud environments are powerful, but misconfigurations can lead to large blast radiuses if not managed properly. Finally, compliance impact. Regulations like HIPAA, PCI, CMMC, NIST 800-171, and FedRAMP all have specific cloud considerations. Cloud logs, access controls, encryption, vendor assessments, these become mandatory, not optional. And auditors expect organizations to understand exactly how their cloud services are configured and secured. When we talk about securing modern cloud environments, one of the most important concepts to understand is the shared responsibility model. This model makes it clear that both the cloud provider and the customer have critical roles in security, but the responsibilities are different. On the provider side, the cloud service provider handles everything related to the physical environment and the core infrastructure. That includes the physical data centers, power, cooling, building access, and hardware security. They also manage the underlying networking, virtualization layers, and the foundational cloud services. In other words, they secure the cloud. On the customer side, we are responsible for everything in the cloud. That means identity and access management, making sure MFA and least privilege are enforced. It includes protecting our data, whether that's through encryption, backups, or classification. We also manage configurations such as security group rules, storage permissions, and logging. And finally, we are accountable for applications and endpoints, because misconfigured workloads or unpatched devices are still our problem, even if they run in the cloud. Now let's walk through the core principles of Zero Trust, because this architecture represents one of the most important shifts in how we secure modern cloud environments. First, identity is the new perimeter. In traditional networks, we protected the walls. In the cloud, there are no walls. Users, devices, and apps connect from everywhere. So identity becomes the primary control point. If we can't verify who or what is accessing resources, nothing else matters. Next, least privilege. Zero Trust demands that users and systems get only the access they need and nothing more. No standing admin rights, no broad access by default. Every permission should be intentional and minimal. That leads directly to MFA everywhere. Multi-factor authentication is no longer just for privileged users. It's required across the board. With stolen credentials being the most common attack vector, MFA is one of the simplest and most powerful controls we have. Another key principle is encrypt data, both in transit and at rest. When we assume the network is compromised, encryption becomes our safety net. Even if data is intercepted, it remains useless to an attacker. Zero Trust also requires continuous monitoring. We don't authenticate once and assume trust forever. We continuously validate user behavior, device posture, network activity, and access patterns. If something looks abnormal, we challenge it. And finally, assume breach. This mindset is what makes Zero Trust effective. Instead of planning for if something happens, we plan for when. That shift forces us to build systems that are resilient, compartmentalized, and ready to contain damage at any moment. When you bring all these principles together, Zero Trust becomes more than a framework. It becomes a culture of continuous verification and minimized risk. When we talk about securing modern cloud environments, identity becomes the front line of defense. In many organizations today, identity is the new perimeter, not the firewall, not the network edge. That means our users, service accounts, and machine identities are now the most critical assets to secure. Let's break down the key components. User identities. These are your employees, contractors, and partners. Every user should have a clearly defined identity with strong authentication and appropriate access. Nothing more, nothing less. Service accounts. In the cloud, applications talk to other applications. Those app-to-app communications use service accounts, and these identities often have far more privileges than human users. Securing them is essential to preventing lateral movement. Roles and permissions. We shift away from individual permissions and move toward role-based access control. Roles define what someone should be able to do, and permissions enforce it. This helps maintain least privilege at scale. Conditional access. This is where identity gets smart. We evaluate context, location, device, risk level, behavior, before granting access. It's a zero-trust principle. Never trust, always verify. Multi-factor authentication, MFA. MFA is the minimum standard today. Passwords alone are no longer enough. MFA dramatically reduces compromised account incidents and is required by nearly every major compliance framework. Single sign-on SSO improves both security and user experience. By centralizing authentication, we standardize policy enforcement, reduce password fatigue, and gain better visibility into identity behavior. Together, these elements create a strong identity foundation. If we get identity and access management right, we reduce the majority of modern cloud security risk before attackers ever reach a system. When we talk about securing modern cloud environments, data protection becomes one of the highest impact areas of security. Cloud systems store massive amounts of sensitive information, so we have to make sure that data is protected at every stage, at rest, in transit, and in use. Let's break down the key elements. Encryption keys, strong. Encryption is essential, but it's only as good as your key management. We must securely generate, store, rotate, and monitor encryption keys, often using cloud-native services like AWS KMS, Azure Key Vault, or GCP KMS. Good key management prevents unauthorized decryption, even if data is exposed. Tokenization replaces sensitive data, like credit card numbers or PII, with non-sensitive placeholders. This helps reduce compliance scope and minimizes risk because the real values aren't stored inside operational systems. Secure storage, cloud storage, buckets, databases, file systems must be configured securely from day one. That means encryption by default, access controls, restricted public exposure, and continuous monitoring for misconfigurations. A single open bucket can expose an entire organization. Data classification. Not all data carries the same risk. Classification helps us determine what needs the highest level of protection. Public, internal, confidential, and regulated data like HIPAA, PCI, or CUI should all have clearly defined handling requirements. DLP tools, data loss prevention tools help detect and block sensitive information from leaving the organization. In the cloud, DLP integrates with email, storage services, endpoints, and even generative AI interfaces to prevent accidental or malicious data leakage. Backups, finally, secure backups are non-negotiable. We need immutable, encrypted, and versioned backups with proper retention policies. This is our safety net, not only for disasters, but also for ransomware, accidental deletions, or corrupted deployments. Now let's shift into the architectural side of securing cloud workloads. No matter which cloud provider we use, AWS, Azure, or Google Cloud, the foundational concepts are very similar. First, we have VPCs or VNets, which are essentially our private, isolated networks in the cloud. Think of them as the cloud equivalent of creating your own internal network segment in a data center. This is where we control IP ranges, routing, and how traffic flows. Inside those, we define subnets. Subnets allow us to separate resources by function, sensitivity, or exposure. For example, we might use public subnets for load balancers and private subnets for databases. Subnetting lets us manage security boundaries and reduce blast radius. Next, we have security groups. These act like virtual firewalls at the instance or service level, controlling which traffic is allowed in or out. In the cloud, everything is deny by default, so these rules must be explicitly defined. Security groups are a critical zero-trust control. They ensure workload-level segmentation. On top of that, providers offer cloud firewalls, which apply broader network inspection, threat signatures, and more advanced filtering. These might be provider-native or third-party solutions like Palo Alto or Fortinet. They help catch malicious patterns before they reach individual systems. Finally, private endpoints are becoming essential. They ensure that services like storage accounts, databases, and APIs can only be accessed over private network paths instead of going over the public internet. This eliminates a huge amount of exposure and dramatically reduces attack surface. Together, these components form the backbone of secure cloud network architecture. They allow us to isolate systems, enforce least privilege, and keep workloads shielded from external threats. Now let's tie everything together with the core principles of Zero Trust, one of the most important frameworks for securing modern cloud environments. First, Zero Trust is built on the idea of never trust, always verify. We no longer assume anything inside the network is safe. Every request, whether it comes from inside the office or from a remote laptop, must be validated before access is granted. Next is assume breach. This mindset forces us to architect systems with containment in mind. Instead of hoping nothing goes wrong, we design as if an attacker is already inside and focus on limiting movement, containing damage, and detecting anomalies quickly. Verify explicitly means authentication and authorization happen continuously, not just at login. We validate identity, device health, location, risk level, and behavior patterns every time a user or workload attempts to access something. Least privilege is another critical pillar. We give users, applications, and devices the minimum access necessary to do their job, nothing more. This dramatically reduces the blast radius of an incident, and finally, continuous monitoring ensures we're not treating security as a one-time setup. We constantly inspect signals, logs, and behaviors to detect misuse, anomalies, and emerging threats in real time. In the cloud, attackers move fast, so our visibility and response must move even faster. Together, these Zero Trust principles build a resilient, adaptive, modern security posture that aligns perfectly with distributed work, hybrid cloud environments, and today's threat landscape. Let's talk about why modern environments demand a Zero Trust aligned security model. First, cloud and remote work have completely changed where our users operate from. People are signing in from home, airports, personal devices, you name it. The perimeter is no longer a building, it's everywhere. Next, we have mobile devices, phones, tablets, laptops, constantly connecting to corporate data. These endpoints move in and out of secure networks, which increases exposure if we don't have the right controls in place. Then there's SaaS sprawl. Organizations are using dozens, sometimes hundreds of cloud applications. Each app introduces new identities, new data flows, and new risks. Without central governance, SaaS becomes one of the biggest blind spots in the enterprise. Traditional VPNs also have limitations. They were built for a world where a small number of employees occasionally worked remotely. Today, VPNs often create bottlenecks, introduce latency, and worst of all, grant too much implicit trust once a user connects. Finally, we need to consider lateral movement threats. Attackers no longer stop once they compromise a single machine or credential. They move sideways through the network, escalating privileges and targeting high-value assets. This is exactly why Zero Trust principles like segmentation, least privilege, and continuous verification are so important. In short, our environments are more distributed, more dynamic, and more complex than ever, so our security strategies must evolve accordingly. Now let's walk through the core pillars of Zero Trust. These are the foundational layers that every modern security architecture must address. Zero Trust isn't a single product or tool, it's an operational model built across your entire environment. First, identity. Identity becomes the new perimeter. Every user, whether employee, contractor, or service account, must be authenticated, validated, and continuously verified. This means enforcing MFA, strong identity governance, and conditional access so the right person gets the right access only when needed. Next is device security. Even with strong identities, compromised devices create risk. Zero Trust requires knowing the health and posture of every endpoint: laptops, mobile devices, virtual machines, and servers. We need device compliance checks, endpoint detection and response, and the ability to block or quarantine devices that don't meet policy. Network security. Traditional networks rely on trusted internal zones, but Zero Trust collapses that idea. We segment the network, restrict lateral movement, and enforce microperimeters. Whether traffic is internal or external, it must be explicitly inspected, authenticated, and authorized. Application security. Applications are one of the biggest attack surfaces today, especially SaaS and cloud apps. We validate access at the app layer, enforce least privilege, and monitor behaviors like impossible travel or unusual login patterns. Application level zero trust also means secure coding practices and continuous monitoring. Data security. Ultimately, zero trust is about protecting the data itself. That requires classification, labeling, encryption at rest and in transit, and strong access controls. We ensure only the right identities and devices can interact with sensitive data, and we monitor for misuse. Analytics. Zero trust depends on visibility. We need real-time analytics, behavioral analysis, and threat intelligence to understand anomalies and detect suspicious activity. This is where security teams gain insights into what's happening across identities, devices, apps, and networks. Finally, automation. Automation ties everything together. With environments moving fast, manual security simply can't keep pace. Automated policy enforcement, automated remediation, and automated access decisions ensure consistency and dramatically reduce response time. Together, these pillars form a complete zero-trust strategy, one that improves security maturity, reduces exposure, and supports modern cloud-first environments. As we move deeper into zero trust, it's important to understand how this model is actually implemented. Zero trust isn't just a slogan. It's a series of technical practices that fundamentally reshape how we control access and protect systems. First, zero trust is identity-focused. In the past, the network perimeter was the primary line of defense. But today, identity, both human and machine, is the new perimeter. Every request is tied back to who or what is asking for access. That means robust identity governance, strong authentication, and continuous validation of user roles, privileges, and behavioral patterns. Next, we have device validation. In a modern environment, we don't just trust that a device is safe because it's on our network. Zero trust requires verifying device health, compliance, and configuration every time it attempts to access a resource. Is it patched? Is it managed? Is it encrypted? We verify these factors before granting access, and if the device fails, access is denied or restricted. Another key technique is microsegmentation. Instead of relying on one big open network, zero trust breaks the environment into smaller, isolated zones. This prevents lateral movement. If an attacker compromises one asset, segmentation ensures they can't easily pivot to others. In practice, this can be implemented through software-defined networking, identity-based segmentation, or application-level isolation. Finally, we have continuous authentication. This is a shift away from the traditional login once and you're good for the day model. Access is continuously reevaluated based on behavior, location, device posture, and risk signals. If something changes, like unusual activity or high-risk behavior, the system automatically adjusts, requiring re-authentication or restricting access. Together, these elements, identity-focused device validation, microsegmentation, and continuous authentication, form the operational backbone of zero trust. They help ensure that access is always justified, continuously evaluated, and tightly controlled, dramatically reducing the chances of successful breaches. Now let's talk about some of the key technologies that support securing modern cloud environments and enabling zero trust in practice. First, CASP, Cloud Access Security Brokers. CASP sit between users and cloud services, giving us visibility and control over data in SaaS applications. They help enforce policies like DLP, access controls, and threat detection across cloud apps that we don't fully manage ourselves. Next is CSPM, Cloud Security Posture Management. CSPM tools continuously scan your cloud configurations for misconfigurations, policy violations, and drift from security best practices. In cloud environments where everything is software-defined, secure configuration is half the battle, and CSPM gives us that oversight. Then we have CWPP, Cloud Workload Protection Platforms. CWPP focuses on the workloads themselves, virtual machines, containers, Kubernetes clusters, serverless functions. These tools help monitor behavior, block threats, and secure workloads consistently across hybrid and multi-cloud environments. Another major category is SASE, Secure Access Service Edge. SASE unifies networking and security controls into a cloud-delivered framework. It's what enables modern remote access without relying on old VPN architectures. It combines SD-WAN, Zero Trust Network Access, secure web gateways, CASP, and more, delivered globally at the edge. We also rely heavily on SIEM XDR. SIEM aggregates logs and events from across the environment, while XDR adds analytics, correlation, and automated threat detection across endpoints, identities, networks, and cloud services. Together, they provide the visibility and detection logic that Zero Trust depends on. Finally, cloud-native security, solutions built directly into platforms like AWS, Azure, and Google Cloud. These include IAM roles, security groups, WAFs, logging services, encryption tools, and native monitoring services. Cloud-native tools are often the first layer of defense and should always be properly configured as part of your baseline security strategy. All of these technologies work together to create layered, adaptive security, enabling real Zero Trust and allowing us to secure distributed, rapidly changing environments. When we talk about securing modern cloud environments, one of the most important things to understand is that most breaches aren't caused by advanced nation-state tactics. They're caused by avoidable configuration mistakes. So let's break down some of the most common cloud security failures we see today. First, misconfigured storage. This is overwhelmingly the number one cause of cloud data exposure. Public S3 buckets, unsecured blob storage, misconfigured ACLs, these issues lead to massive breaches. Anytime storage is created in the cloud, the default should be private, encrypted, and locked down with least privilege. Second, excessive permissions. The convenience of give them admin access so it works is one of the biggest risks in cloud environments. Over-permissioned IAM roles, service accounts with broad access, and unused privileges expand the attack surface dramatically. Zero Trust requires we tightly control and continuously validate permissions. Third, no MFA. Not enabling multi-factor authentication for admins, developers, or even end users is increasingly indefensible. Compromised credentials remain the number one root cause of cloud breaches. Enabling MFA, especially phishing-resistant methods, is one of the highest impact defenses you can implement. Fourth, unpatched workloads. Even in the cloud, vulnerabilities don't fix themselves. Virtual machines, containers, and serverless functions all require patching or runtime security controls. Attackers automatically scan for exposed, unpatched services within minutes. Fifth, shadow IT. Teams spinning up cloud resources outside of IT oversight leads to unmanaged risks, unsecured applications, unmonitored data flows, and gaps in visibility. Shadow IT not only increases risk, but also undermines compliance, governance, and cost control. Across all these issues, the theme is the same. Cloud security fails when visibility, governance, and identity controls are missing. Modern cloud environments require strong architecture, continuous monitoring, and a zero-trust mindset to stay secure. Thank you for joining me on another episode of Technology and Cybersecurity Explained.